our day? I hope very well. Today, my partner, Vanessa Roa, and I, Joanna Vargas, will talk about diode, specifically two types of diode. I hope you enjoy it.
A diode is a semiconductor that allows the passage of electric current in a single direction with characteristics similar to a switch. So, a diode works in this way. It only lets through a single of current. In order to work, it converts power and alerting current AC to direct current DC, and sending it in one direction only by isolating the positive pulse from the negative pulse and vice versa.
There are several types of diode, as we can see in the image. Each one has its own symbol and function. We will talk about the tunnel diode and the light emitter. It is a semiconductor diode that has a P-N junction in which the tunneling effect occurs that give rise to a negative differential conductance in a certain interval of the current voltage. The presence of the negative resistance section allowed its use as an active component, amplifier, and oscillator.
This diode was invented in 1958 by the Japanese physicist Leo Szaki, for which they received a Nobel Prize in 1973. He discovered that a semiconductor diode obtained with a much higher degree of contamination of the basic material that usually exhibit a very particular voltage current characteristic. The current began to increase almost proportionally to the amplified voltage until I reached a maximum value called a peak current.
From this point, if the applied voltage continues increase, the current began decrease and continue to the until averages of minimum, called the valley current, from which increase again. The growth of the current is at first slow, but then it becomes faster until it destroys the diode if it's not limited in some way.
Characteristic of the tunnel diode. When reserved diode is amplified, the Fermi level of the p side become higher than the Fermi level of the inside. Therefore, electron tuning for the p side equilibrium band to the n-side conduction band takes place. With reserve bias, noting the current tunneling also increases.
Bias is applied, the Fermi level on the n side becomes higher than the Fermi level on the pi side. So the tunneling of the electrons from the inside to the p side occurs. The amount of tunnel current is very large than the normal junction current. When the forward bias is increased, the tunnel current increases to the certain limit.
When the inside band age is the same as the Fermi level on the p side, the tunnel current is the maximum. With the further increase in forward bias, the tunnel current decreases and the way of time and this negative conduction region. When the forward bias is arises further, we obtain the normal conjunction current of the Pn, which is exponentially proportional to the voltage.
Symbol. The tunnel diode is a type of CS diode that is capable of operating very fast in the frequency range of microwaves. It's a quantum mechanical effect that is not as tunneling. It is ideal of oscillators and receivers, because of its negative slope characters, but I cannot be used in large integrated circuits, so its applications are limited. The tunnel diodes can make a very stable oscillator circuit when coupled to a tunnel circuit or cavity bias at the center point of the negative resistance region. Here is an example of a tunnel diode oscillatory circuit. Tunnel diode oscillators are intended to operate at microwave frequency. Generally use some form of transmission lines as a tunnel circuit. These oscillators are useful in applications that require a few milliwatts of power. For example, local oscillators for the superelectro microwave receiver.
The light emitting diode or LED is a light source that emits photons when a very low intensity electric current is received. The LED is usually enclosed in a chloride plastic material that accentuates the wave generated by the diode and help focus the light into them. A typical light emitting diode and this Shem's symbol and showing figure. The positive terminal of anode is usually the longer on the two terminals. Some LEDs have a flat base that serves to identify the negative terminal of cathode.
How it works? Again, directly present to the LED use cause of production of photons as a result of combination between electrons and holes. It should be considered that the intensity of the light is relative to the amount of current flowing through the device, as well as a radio in the wavelength that corresponds to each color. Okay. If the polarization voltage is increased, the LED diode begins to emit photons, and we're observing a beam of light if the emission voltage was reached therefore, as the polarization voltage increases, the intensity of light emitted increases, considering that by increase the voltage, as therefore the intensity of light emitted. There is also an variation to the increase in the intensity of the current and can be decreased by our combination. It is important to remember that an LED has a voltage drop 1.5 to 2.5 volts. When polarized directly, the voltage drop varies depending on the side of LED color composition and other factors.
Parts 1. Epoxy resin encapsulation. 2. Semiconductor light emitting diode. 3. Reflector cube or reflecting cavity. 4. Anvil. 5. Pool. 6. Base. 7. Flat base. Identify the negative terminal. 8. Connection terminal negative. 9. Connection terminal positive. 10. Connecting wire of whisker.
Polarity of a LED diode. A LED diode can only be polarized directly. This means that its conduct current at mid-light, while being inversely polarized, it doesn't conduct current and doesn't emit light. It is important to include the serial current limiting resistor in the circuit to avoid excessive forward current, which can damage the LED diode.
Advantage 1. Long life. 2. Low power consumption. 3. High level or efficient. 4. Reduced dimension. 5. Immediate light when switched on. 6. Higher resistance to shock or vibration. 7. Wide range of resistance to temperature variation. 8. No UV or IR radiation.
And this is the bibliography we use. And this. Thanks. See you later.